This video is an introduction to right triangle trigonometry. So given a right triangle ABC with angle C equals 90 degrees. So ABC is the name of the triangle. Angle C will be 90 degrees when we refer to it this way. You're telling us a right triangle, that's what makes it a right triangle, that we have one angle that's 90 degrees. And if I was to sketch this out, the right triangle would look like this. The right angle is a 90 degree angle, that's angle C. A and B doesn't really matter where you put them, you just have to be accurate enough. So I'll call that angle A, and I'll call this angle B. So those are the ABC. The capital letters refer to the angles. And then we talk about these lowercase letters, which will be the sides. So the sides are always going to be opposite the angle. So if I have angle A here, side lowercase a will be across from it, or opposite of it. For angle B, across from there would be side lowercase b. And across from angle C will be lowercase c. Now, lowercase c, this side has a special name. So we don't talk about it in terms of the opposite. We really talk about it as the hypotenuse. Alright, so the hypotenuse of a right triangle is the side that's opposite the right angle. So given a right triangle ABC with angle C equals 90 degrees, then we have a relationship between the sides where we say a squared plus b squared, so side a squared plus side b squared is equal to the hypotenuse squared, which is c squared. And it's important that the hypotenuse is always on the side by itself. A squared and b squared can be interchanged because addition can be done in either order. We call this, you probably heard of it before, Pythagorean Theorem. So Pythagorean Theorem only has to do with right triangles, and it tells you that when the legs, they call these the legs of the right triangle, the leg squared plus the other leg squared is equal to the hypotenuse squared. So knowing that, we can make some deductions about which sides have which lengths if we know that relationship. The other thing we use is what we're going to call our trigonometry functions. So suppose I let x equal, so I'm just going to write this as a separate thing. So let x equal an acute angle in a right triangle. Now when I say that, an acute angle is not the 90 degree angle. So it's one of the other angles, because an acute angle has to have a measure less than 90 degrees. So let's say I was to draw a right triangle here. And the right angle, is there. And I'm going to say, let's call x, what I just called x, one of the angles. So I'll call x this one here. You could call it the other one. It doesn't really matter, but for the reference I'm going to call it x this angle here. Well, then we have ways of describing the sides of the right triangle. The hypotenuse is still always the hypotenuse, the side opposite the right angle. Now, from angle x, the side directly across from it we call the opposite. Alright, so the side opposite angle x would be the one directly across from it. The side right next to it, right, that's not the hypotenuse. So the side next to it that's left here, the other leg, is called the side that's adjacent. Adjacent means next to. So the side that's next to it is adjacent. And from there we have relationships between these three sides and that angle x. So we have what we call the trigonometric functions. Alright, so we have for short I'll call them trig functions. And the trig functions are sine, cosine, and tangent. Right? So those are the names of the trig functions. And the way you work with them is you take the angle, and depending on the relationship with the angle, it's called sine, cosine, or tangent. So for short, we call sine, we use sin for sine. And we say sine of x. It's a function, so it has parentheses, not necessarily parentheses, but it's the sine of a value. I'm putting parentheses here so you understand it's sine of x. It's sine of that angle. And sine is always equal to the opposite over the hypotenuse. So it's opposite over the hypotenuse. So if I said find the sine of angle x, you would give me the number for the opposite side or the number of the hypotenuse. The cosine of x, right? Again, it's a function. You need the x there to show that it's of x, because it's specific to this angle. It's not this other angle. Cosine of x is equal to adjacent over hypotenuse. So adjacent over hypotenuse. And the tangent of x is equal to, here's x, the opposite over the adjacent. So opposite over adjacent. And, you know, you do have to memorize these relationships, but these help us find out, you know, what angle has what relationships with which sides, and it also can help us find the angle if we need to. A short way of remembering this, sine, you know, SOH, cosine, CAH, taking the first letter of each, and tangent would be TOA. SOHCAHTOA is one way people remember it, SOH, CAH, TOA. It really means sine is equal to opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. That's how that would help you remember it. Some people use a mnemonic device. Some old horse caught another horse taking oats away. So we've heard that before. One that people have, you know, it's kind of dated, but some old hippie caught another hippie tripping on acid. You know, those are ways people remember it. People kind of think that last one's funny, but it's a way to remember it, but you have to memorize these. So let's talk about, you know, evaluating them and finding them. So if I said, I'll call this example. Right, so for right triangle ABC with A equals 5 and C equals 13, find sine of A, cosine of A, and tangent of A. Now you might hear this as find all three trig functions for angle A. Those are the three they're talking about. There are other trig functions that you'll learn in a later course, but so they don't give you the picture here, so let's draw it first. All right, so for right triangle ABC, so you know, here's a right triangle. Remember, C is our right angle. A and B are interchangeable. I'll call this A, and I'll call this angle B. Make sure, you know, capital letters for the angles, it matters. And then it says, with side A equals 5. Well, which side is A, lowercase a? Well, it's the one that's opposite of angle A. So this is 5 here. And it says C is equal to 13. C is the side opposite the angle C, which is the hypotenuse. So this will be 13. And then it says find, you know, sine A, cosine A, and tangent of A. So find the trig functions for this angle A is what it's talking about. Right, that's how you know which angle they're talking about. You need that in there. So I'm looking at this angle here. Now to find the trig functions, you need the opposite, adjacent, and hypotenuse. Now, what do I have so far? Well, I have the opposite of angle A, and I have the hypotenuse, but I don't have the adjacent. So the first thing I would do is try to find this side here, which I'll label lowercase b. You can call it, you know, any variable you wanted, really. But I'll label it lowercase b because it's opposite angle b. So the first thing I want to do is solve for that side, because then I have it. All right, so I'll solve for side b. Now to solve for this side, remember for a right triangle, right, it has to be a right triangle, we have a special relationship between the sides, and we mentioned on the previous page. It's Pythagorean Theorem. So if you know two of the sides, you can always find the third. So solving for b, remember it's the leg squared, so 5 squared plus the other leg squared, b squared, equals the hypotenuse squared, so 13 squared. The hypotenuse always has to be on the side by itself when you're squaring it. So 5 squared is 25 plus b squared equals 13 squared, which is 169. If you don't know it, you can use your calculator. We're going to solve for b. So we're going to subtract 25 to isolate the b squared first. So I end up with b squared equals 169 minus 25 is 144. And then you want to take the square root of each side. Now normally when you take the square root, you put plus or minus, but because we know this is the length of a side, we know it can't be negative. So I'm just going to leave this as the positive. So b is equal to the square root of 144. It evaluates, nicely evaluated. If it doesn't, simplify the radical and keep it exact. But square root of 144, we should know is 12. So side B is equal to 12. So now I know when I go to look at this triangle, right, this side here, B, now equals 12. Right, so we know now we have 5, 12, and 13. But the question didn't ask us to actually find that. It actually has to find the sine of A, cosine of A, and the tangent of A. So let's go through and do that. So to find the sine of A. Now, you see it here without parentheses, but that still means sine of A. It's a function of A. So remember, we're looking at angle A. If you're looking for sine of B, that'd be something very different. So the sine of A is what? Well, what's the relationship between sine? Sine is, going back here, is opposite over hypotenuse. So the sine of A is opposite over hypotenuse. So following that from here, here's A. What's opposite of it? Opposite of it is 5 over the hypotenuse, which is 13. So the sine of A is 5/13, and that's your answer. Unless we ask for you to make it a decimal, you want to keep it as a fraction. Cosine of A. So again, you're starting at angle A, and we want cosine of it. Cosine is what relationship? Cosine is adjacent over hypotenuse. All right, we have it here. So here's A. Adjacent means next to, and you can't count the hypotenuse as being next to because it's a special side. So adjacent to A, that side next to it is 12. All right, so we want adjacent over hypotenuse. Adjacent is 12 over, what's the hypotenuse? The hypotenuse is 13, so you got 12/13. So the cosine of A is 12/13. Now let's take a look at the tangent of A. The tangent of A, remember what tangent was equal to? Tangent was opposite over adjacent. So opposite of angle A, so let's write it down so we see what we're looking at. So we want opposite over adjacent. So opposite of angle A is 5. Adjacent to angle A is what's next to it? 12. So it's 5 over 12, and you got it. So we have 5/12. Now if any of these reduced, you would reduce them. If any of them had a radical in the denominator, you would have to rationalize them. These are exact answers right now. All right. If we ask you to round, then you can round, but if not, we want to find them exactly. You want to leave them as a fraction. So, once you know all three sides of a right triangle, you can find these based on the angle they told you. Now, if I asked you to look at, instead of sine of A, cosine of A, and tangent of A, what if I said find the, now this is not the question, but let's just do it just so you can understand it. If I said to find the sine of angle B, well, the sine of angle B, here's angle B now, so I'm really talking about this angle down here. All right, that's angle B. If I'm saying the sine of angle B, I want still, sine is opposite over hypotenuse, but now they're not the same values, right? From angle B, the opposite side would be 12 over the hypotenuse, well, that's still 13, that doesn't change. So sine of B would be 12 over 13. The cosine of B, here's angle B, cosine is, remember, adjacent over hypotenuse. So what's adjacent to B? 5 over the hypotenuse, which is 13. So cosine of B would be 5/13. And if I asked you for the tangent of B, remember that's opposite over adjacent, but now from angle B, what's opposite of it? Opposite is 12 over adjacent, which is 5. And so it would be 12/5. So this is why it matters that you have an argument here of, what angle you're talking about, because the sides are different, because opposite and adjacent mean different things based on different angles. So making sure you're paying attention to which angle you're looking for when they ask the question. Let's do another one like this. So if I said, for this example, for the triangle below, determine sine of A, cosine of A, and tangent of A. So this time I'm going to give you the triangle so you don't have to draw it for yourself. We're going to draw it together here. But let's say I drew this triangle here. Here's the right angle. I'll call this angle A. this one B, and this one C. So they're not in the same order as before, and the triangle's not even the same orientation, but the idea is still the same. You know where the right angle is, so you know the hypotenuse is opposite of it. And I'm going to tell you that this side here is going to be 6, and this side here is going to be 2. So lowercase a would really be 2, and lowercase b is 6. And then I'm going to leave this as C. Lowercase c here, right? It's opposite the hypotenuse. Now, if I didn't write anything there, you would still have to label it yourself. You could call it x, call it whatever you'd like. So for this triangle, right, we're trying to find sine A, cosine, and tangent A. Now, you might want to pause this and try it for yourself. But what would you do first? First thing is, you probably want to find that side C, because you're going to need it. So the first thing we're going to do is solve for C. Right, so for side C. Well, how do you find that side? Well, if you know two other sides, what do we use? Pythagorean Theorem, right? A squared plus b squared equals c squared. Well, now when you say a squared, right, technically it's 2 squared plus b squared, well, that's going to be 6 squared equals c squared, which is just in this case, we'll keep it as c squared because we don't know what c is. The order of these doesn't really matter because addition is commutative. You can do it in either order. 2 squared gives us 4, plus 6 squared gives us 36, and it's equal to c squared. Remember, the hypotenuse is always a side by itself. So then we got 4 plus 36 is 40 equals c squared. So to solve this for c, remember, you take the square root of each side to get c by itself. Remember, I don't need plus or minus because this is the length of a side. It has to be positive. So we got c is equal to the square root of 40. Now, is square root of 40 a perfect square? Well, no. But does square root of 40 have any perfect square factors? It does, right? Square root of 4 is a perfect square factor times a non-perfect square factor, square root of 10. So you get c equals square root of 4 is 2, so we get 2 square root of 10. Now, remember, this is the length of the side exact, right? When we say exact, it means you don't want any decimals. You want to keep it in the radical form. So this is the exact form, 2 square root of 10. It's simplified because we simplified the radical, but the exact form is here. So this length of this side, c, right, this part here is 2 radical 10. That's what we just found. That's what you're going to use for the value if we need to. So now let's do the trig functions, right? That's what we're trying to find. So you're looking for sine A, cosine A, and tangent of A. So the sine of A, well, what's the sine function? Sine means we want opposite over hypotenuse. So remember, the angle you're looking at is important. Sine of A, this is angle A. So what's opposite of it? Opposite of that is 2 over the hypotenuse. Well, the hypotenuse is side C, we just found, was 2 square root of 10. And then you want to simplify this. Now, simplifying this, the first thing you can do is 2 divided by 2 cancels to a 1. Make sure you double 1 in the numerator. So you have 1 over the square root of 10, just reducing that. And then you want to rationalize this, remember, because radicals in the denominator can cause issues. So we're going to rationalize this times the square root of 10 times the square root of 10. So we get the square root of 10 over, remember, the square root of anything times itself is just whatever was on the inside. So square root of 10 over 10. And that would be the answer for the sine of A. Make sure you rationalize, right? Make sure you simplify. For cosine A, right? What's cosine? Well, cosine is adjacent over hypotenuse. Remember, this is angle A. You have to do it based on the angle we're looking for. What's adjacent? Well, what's next to it? Well, that's 6. Remember, adjacent is next to it, but not the hypotenuse ever. The hypotenuse is its own special side. So the adjacent is 6 over the hypotenuse, which is 2 square root of 10. And again here, you might notice 6 and 2 can reduce. 6 divided by 2 gives me 3. 2 divided by 2 cancels to a 1. So I end up with, I've got 3 over the square root of 10. And then you want to multiply by what to rationalize? Well, you want to multiply by square root of 10 over the square root of 10. So multiply both numerator and denominator by square root of 10. So you end up with the square 3 times the square root of 10 over square root of 10 times square root of 10 is just 10. If this reduces, you reduce it. If it doesn't, you leave it alone. Similarly here, you know, these happen to reduce in that first step, but if they didn't reduce, you just have to leave them alone. It doesn't change anything. You need the numbers there. You should remember how to rationalize from our previous sections. And then the last one we need is tangent of A. Well, tangent is what? Tangent is opposite over adjacent. So if I'm talking about opposite over adjacent here, what's opposite of angle A? Well, opposite of it is 2 over the adjacent, which is 6. That's what's next to angle A. And then we reduce this. 2 over 6 reduces to, right, 1/3. You should know that at this point, but making sure you got there. It's a 1/3 in case you can't tell. It's a 3. Right, because 2, divided by 2 gives you 1. 6 divided by 2 gives you 3. So you get 1/3. And this one, you don't need to rationalize. There's no radical in the denominator. So don't start just multiplying all your denominators all the time. It's really based on, if you have a radical in the denominator, that's when we rationalize. So the sine of A is square root of 10 over 10. The cosine is 3 times square root of 10 over 10. And the tangent is 1/3. These are exact values because we left them with the radical in there. If I ask you to approximate it, you can approximate the radical on your calculator. But otherwise, you should show it. Let's quickly talk about using your calculator in the trig functions. So on your calculator, you have buttons that go along with the trig functions. Sine, cosine, tangent. Alright, so they look like that. Sine, cosine, and tangent. And you should make sure that you're in degree mode when you're using it. So you have this DRG button. See it right there on my calculator. You might be in a different spot. But when I turn it on, down on the bottom, see how it says DEG there? If I hit that DRG button, it changes from degrees, radians, or gradients. You want to make sure it says DEG and not RAD or GRD. So we want degree mode. So that's important because we're talking about degrees in this course. Other courses use different angle measures and that's what those are, but we want degree mode. So make sure you have degree mode on. That'll be important as we go forward. And sometimes, we're going to know what the angles are. So far we haven't known the angles. Sometimes you're going to know what the angles are and you want to find the trig function for them. So that's how we use the sine, cosine, and tangent button. So, for example, if I just said to evaluate. Now these are approximations when we do this, typically, except for some special cases. But if I said to evaluate, and the first one we'll look at is the sine of 32 degrees. What you're really doing is you're figuring out the ratio, that relationship between the opposite and hypotenuse, because sine is opposite over hypotenuse of 32 degrees. So you're finding what that relationship has to be. So we're going to approximate it in our calculator. Now, if your calculator displays everything on the screen like mine, it's as easy as typing in sine 32 and then hitting enter. And you get 0.529919. I'll just put 0.5299 to 4 decimal places, and then this, these dots to indicate that it's going to continue on. Not in a pattern, but just that it continues. So 0.5299. If your calculator does not display everything on the screen like mine does, then you would have to type in 32 first and then hit the sine button. You should get the same answer, 0.5299. Make sure you do. You might want to try these next two for cosine and tangent on your own. They're similar, right? Because the cosine of 48 degrees and the tangent 21 degrees. This is really just to make sure you understand how to use your calculator. So the cosine of 48 degrees, for me, I do cosine 48, hit enter, and I get 0.6691. So this is, I'll just point 0.6691 just to 4 decimal places. Now if your calculator does not display it on the screen, remember you type 48 first, then hit cosine. And then this gives you a relationship between the adjacent and hypotenuse, really, for a 48 degree angle. And then for tangent of 21 degrees, we'll do tangent 21, hit enter, and I've got 0.3838, gets rounded up to 9 there, so 0.3839 we'll say. So I'm rounding this to 4 decimal places. Now, it should be fairly straightforward how to use this. You only use this, though, if we're asking you to evaluate the sine, cosine, or tangent of a specific angle. If you don't know the angle, you can't use this, and this is just for an approximation. All right, so it gives us a decimal approximation of the relationship between the sides each represents, either opposite over hypotenuse, adjacent over hypotenuse, or opposite over adjacent. Now, on these buttons, the sine, cosine, and tangent buttons, you can see you've got these inverse trig functions, or what we call the arc sine, arc cosine, and arc tangent. So see that sign with a little -1, right? So it's like right up above the button. Yours might look slightly different. All right, but you see sine, cosine, and tangent with a -1. Those are inverse trig functions. Really what they're doing is it helps you find the measure of angle if you know the relationship between the sides, right? So you can use these. So you can also use the calculator to find an angle given the ratio between the sides by using the what we call arc or inverse trig functions. So the way you would describe these are, we call it arc sine. I'll write it more clearly. Arc sine. Now if I was just saying of x, I would say arc sine of x, or this also means arc sine of x, the inverse sine of x. It does not mean an exponent on there. It's not 1 over sine x. Don't get those confused. This is just a notation. It's not a direction. Arc cosine of x, or cos, the little -1 there. Remember, it's not an exponent. It really means the arc cosine, or the arc tan of x, or arc tan, or the inverse tangent, written like that. So they call these the arc trig functions or the inverse trig functions. To get to them on the calculator, you hit the second key on the specific trig function, right? That's how I'll get to the part on the blue. So, for example, given sine of x equals 0.5299, find the measure of angle x. Well, again, this is right. They're telling you the sine of x is equal to 0.5299. So they're giving you the ratio of the sides, the opposite over hypotenuse, and they're asking you to find the angle that has that sine. Right? So what we're really doing is when you see that you're trying to find an angle, that's when you're using the arc trig function, using that this case sine. So we know that x has to be equal to what we call the arc sine of 0.5299, and that's how you're going to get the angle that has a sine that's equal to 0.5299. So using the arc function, the arc trig function, the arc sine in this case, so second on the sine key gives you the arc sine of 0.5299. Hit enter. You get 31.9986, right? So if I do this, I got 31.9986, and it keeps going. Right, and this is what? Well, this is the angle, so it's measured in degrees. Now, if I wanted to approximate this, let's just say, to the nearest tenth, that would round this up to 0.0, and then this would be a 2, so it would be 32.0 degrees. Well, let's take a look up here. Remember when I did the sine of 32? What did it come out to? It was 0.5299, and there's more digits. So pretty close, but the idea being that, okay, if the sine of 32 equals 0.5299, the sine of what angle equals 0.5299? Well, it should be 32-degree angle. So you use the arc trig function when you don't know the value of the angle. And that's what we did here. Right? That's what you saw in this example. So, we used it for sine because sine was the trig identity they used here, or the trig function they used to show us the ratio. If they had used cosine or tangent, then you would use the arc of the corresponding trig function. Let's take a look at an example of where you would use this. So, for example, if I said you were given this triangle, I'm going to draw it for you. So it's going to be a right triangle. Call the right angle angle C. This will be angle A. This will be angle B. And I'm going to tell you some information. I'm going to tell you the hypotenuse is 30. I'm going to tell you angle A here is 22 degrees. And that's all I'm going to tell you. All right, so you don't know, you don't know these two sides, and you don't know that angle. What I'm going to ask you to do is solve the right triangle. Now when I say solve the right triangle, it really means find all unknown sides and all unknown angles, right? So this really means find all unknown sides and angles. That's all it means. So, one thing you should do is notice that if you have two of the angles of a triangle, you can always get the third angle, because the sum of the angles of a triangle equals how many degrees? Well, it equals 180 degrees. So if you're trying to find the third angle, right? So I'm trying to find, let's say, angle B to start, right? I can find that pretty easily. It's 180 minus the 90-degree angle minus the other angle you know. So angle B is equal to 180 degrees total in a triangle minus 90 degrees for the right angle minus 22 degrees for the angle you know. So that's how you find the angle that's left. And that'll give us, if you do it, right, 180 minus 90. We know that's 90 minus 22. Oh, we got 68, so this equals 68 degrees. So I know angle B now is 68 degrees. I found it. So angle B equals 68 degrees. Now, how do I find these unknown sides? Well, right now, these unknown sides, if I was to label them, I'll label this lowercase a, and this one opposite of b would be lowercase b. You can't use Pythagorean Theorem because you need 2 out of the 3 sides to use Pythagorean Theorem to find the third. So right now, I don't know 2 of the sides. This is where what we just talked about comes into play, though. If we know an angle, and we can find the relationship between the angle and the side, then we can actually go through and use some of this information. So let's say I want to solve for side A, right? So we'll do that first, right? So we'll solve for lowercase a. To solve this for side A, right, what you're really going to do is use an angle you know. So I could use either A or B. I'll use A because it's the one they gave us, because then you could technically do this without even knowing angle B. So I'm going to pick which angle to use. You have to pick that too. You can't use the right angle, but you have to pick one of the non-right angles. So I'm going to use angle A when I do this. Decide that first. It'll make this easier. So if I'm using angle A, I know that angle A is 22 degrees. That's fine. And I want to solve for side A. I need to come up with a relationship that uses a side I know and a side I don't know. I don't know side A. What side do I know? I know the hypotenuse. So how does lowercase a relate to this angle? Well, that's opposite, and the side I know is the hypotenuse, so I want to use, for 22, right, it's opposite over hypotenuse, and that'll leave me with an unknown of a there. So this would be the sine of, we said angle A we're going to use, which is 22 degrees, is equal to, remember, it's opposite over hypotenuse, because that's the sine function, so it's a over 30. The way I'm getting this, again, is opposite over hypotenuse. You want to use an angle you know, and you have to pick it, so I picked angle A, and then you want to think about it in terms of, okay, I need a ratio that involves a side that I'm trying to find, and then a side that I already know. Well, the side I'm trying to find is opposite it, the side I already know is the hypotenuse, so that's why I'm using sine, because it's opposite that I'm trying to find over the hypotenuse is what I know. And now I want to solve this for lowercase a. Well, the way you solve this is you actually solve this for any variable. If you have division, you solve by multiplying by whatever you're dividing by. So I'm going to multiply by 30 to each side. So I end up with 30 sine of 22 degrees equals lowercase a. Now that's the exact answer. We want an approximation. Now we know we can use this on your calculator now. So if I clear this out, on a calculator it displays everything on the screen. You can really type 30 times and then just sine of 22. Close that off. Make sure you're in degree mode. Hit enter. And we got 11.238. We'll say we'll just round to the nearest tenth. So I've got A is approximately 11.238. 2. And then that would be the answer. If your calculator does not display it on the screen, you want to start with the inside of the trig function and work out. So you'd hit 22, then sine, and then multiply that value by 30. So you work from the inside out if it doesn't display everything on the screen. So now I know side A. I found it. The side here is 11.2. And now you technically could use Pythagorean Theorem to find side B, because now you would know 2 of the sides. Let's talk about how you would do it using trig, just so if you weren't sure how to get there. Let's just solve for side lowercase b now. Now, suppose you didn't know what we just found. So you have just this triangle, and you're trying to find this side here. You can still use angle A. You have to decide on an angle you know. You can also use angle B. Well, I'm going to use angle A. And now I want to find which side. I'm looking for side B. And that side is adjacent to it, and I need to use a side I already know. The side I already know is the hypotenuse. So which trig function relates the adjacent with the hypotenuse? Well, that is cosine. So the cosine of A, which is the cosine of 22, right, and that's why you have to pick the angle first, because that's telling you which relationship you have with the sides. So cosine of 22 is equal to the adjacent, which is side B, over the hypotenuse, which is what I know, and that's 30. Now you couldn't use tangent, just so you pointed out. You couldn't have used tangent to find these, because then it'd be opposite over adjacent, and you wouldn't know either of them if I hadn't done this first part. So if you don't know either of them at the beginning, you can't use tangent in this case. So it depends on which functions are available to you. All right, so this was adjacent to A. This is the hypotenuse. And now we solve this. Well, how do you solve it? Well, again, I'm going to multiply both sides by 30 here to solve for B. So I end up with 30 cosine 22 degrees is equal to B. And then I'll evaluate it on my calculator. On my calculator, 30 times cosine of 22. And I end up with 27.8. So B is approximately 27.8. Now, if there were units on this, like if this said feet or meters on the original problem, then you would have those here as the units on the sides, but in this case it didn't, so that's all you have. Let's take a look at this example here. If I said this is a little different. If I said given this right triangle here, now I'll call this C, I'll call this A, I'll call this B, and I'm going to tell you that this side here is 4, this side is 13. I'm going to label this one X. And I say find angle A and length or side X. Well, what's easiest to find? Well, in this case, you know you've got 2 of the sides in the right triangle. If you have 2 of the sides, you can use what to find side X? You can use Pythagorean Theorem. So to find side X, remember the hypotenuse is on its side by itself squared, so we can say we have x squared plus 4 squared equals 13 squared. Remember, you can change the order of the legs, but the hypotenuse always has to be on the side by itself. So end up with x squared plus 4 squared is 16 equals 13 squared, which is 169. And then we're going to subtract 16 from each side to solve for x. This should be old news at this point. So you end up with x squared equals 169 minus 16, which would be, what, 153. And then solving this, we take the square root of each side. Normally I'd put plus or minus because I know it's the length of a side. I know it has to be positive, so x equals square root of 153. And does 153 have any perfect square factors? On first glance, you might think no. But make sure you know what the perfect square factors you should be checking are. You know, 1 is always a perfect square factor, but then, you know, you have your list of perfect squares, which would be, you know, 4, 9, 16, 25, and so on. Well, 153, if we check it out, 153 is divisible by 9. So it's the square root of 9. times the square root of 17, which equals 3 square root 17. So that's the length of side x. We're going to keep it in exact form. So that's the exact answer because it's in a decimal form. Now how would I find angle A? Well, to find the angle, right, what did I say we used? If we go back here to find the angle, we use the arc trig functions, right? And we use the ratio between the sides. So let's say we didn't even know what this side was. If I'm trying to find angle A, alright, so to find angle A, what do? Well, I need a trig function that relates the sides I know. Well, from angle A, this side here that I know is the opposite, and the side here that I know is the hypotenuse. So what trig function relates opposite and hypotenuse? Well, that's sine. So really what I know is that the sine of A is equal to 4 over 13, right? So I'm relating the sides I know, and we're trying to find the angle. So the sine of A equals 4 over 13. So how do I find angle A then? Well, if you know that the sine is equal to 4 over 13, to find the angle, remember, you're going to use the arc sine of that relationship. So the arc sine of 4/13. Alright, and now we'll use this here. So, make sure you know this, right? So to find angle A, you want to use the arc sine. The reason we're using arc sine, right, the arc sine of A, is because the relationship between the sides I know was the opposite over the hypotenuse. This is why we're using sine. So if we type this in, right, the arc sine is the second key on your sine. Make sure you hit the second key. 4 divided by 13. And that comes up to 17.92. I'll run to the nearest tenth, so it gives me 17.9. Make sure you know that this is an angle, so it's measured in degrees here. So, A is, I'll use a squiggly equal sign for approximately 17.9 degrees. Now remember, you couldn't use just the fact that the angles add to 180 because you didn't know this angle either. So the only way you could have found the first angle you're looking for is by doing this, using the arc trig functions. Once you have that, then you could have gone back and find angle B using the fact that the sum of the angles of a triangle is 180 degrees. But you could solve this triangle just like we solved the previous one. Lastly, I'm going to give you just a couple to look at. So try these two on your own, and then I'll go through a solution. So if I said given this triangle here, so this is a right triangle. I'm going to say that this is C, this is B, this is A. Not necessarily drawn to scale. Say the side is 12. This angle here, angle B, is 53 degrees. Alright, and I'm just going to leave it at that and say solve the right triangle. So I want to pause, take this down, and try it on your own. The other one that I'll have you look at is this example here, where I'll say given this right triangle here, which I'll label AB and the right angle C, and I'll say this side's 3, this side is 5, this side is X, and that's angle B there. Remember, again, not to scale necessarily, but I'll say find angle B inside X. So I want to pause that and try this one as well. So pause these two, go through, and then we'll look at the solutions here. So for this first one, to solve the right triangle here, first thing I would notice, right, is that, I have angle B, and I have one of the sides, so I want to find the other sides. Now I'm going to use angle B as being 53 degrees, and I know the right angle here is 90 degrees, so if I take 180 minus those two angles, I can get angle A. So the first thing I'm going to do is get angle A. Alright, so for angle A, it's equal to 180 degrees minus 90 degrees for the right angle minus 53 degrees for the angle B that we know. And we have 180 minus 90 minus 53. That comes out to 37 degrees. So I know angle A. So angle A equals 37 degrees, which is good. So we have that part of the triangle solved. Now I want to solve for these sides I don't know. I'll label this one, remember opposite of it is lowercase b because it's opposite angle B. I'll label this side lowercase c because it's opposite our angle C. And I want to find angle B, or side B and side C. So when I do this, I will, solve for them individually. So if I said solve for, let's say, lowercase b, I'm going to choose to use which angle I know. I could use either of the angles, but the one they gave me is probably the easiest because in case I made a mistake here, I don't have to worry about it showing up again. So I'm going to use angle B here, which we know is 53 degrees. And I want a relationship between, to find side B, this is an unknown side, and the side I know. So this is the angle. Side B is the opposite of it, right? And the side I know is what to angle B? Well, it's adjacent. So what trig function relates opposite and adjacent? Well, that would be tangent. So we're going to take the tangent of angle B, which is 53 degrees. And it's equal to, remember, opposite, which is B, my unknown, over the adjacent, which is 12. And now I want to solve this. Let's solve this. I'm going to multiply by 12 to each side. So I've got 12 tangent of 53 degrees equals, here the 12's cancel, I've got B. And then we'll approximate this on our calculators. So 12 tangent of 53, we're at 15.92, so we'll round it to 15.9 to the nearest tenth. So 15.9 is side B. Again, not drawn to scale, right? This looks longer than this, but the idea being that you know how to find it. So that would be side B. To find side C, right? And we can pretend like we didn't do this part, or you could use Pythagorean Theorem and use this result. I'll do it without looking at it though, just so we can talk about it based on the numbers we have. To solve for side C, again, I'm going to use angle B. So angle B is 53 degrees. So from this angle, side C, how does it relate to it? Well, side C is the hypotenuse. And I have to use a side I know. Pretend we never even did that part. What side did I know? They gave me 12. But 12 here is what compared to angle B? Well, that's adjacent. So I'm looking for something that relates the adjacent and the hypotenuse. So what trig function relates the hypotenuse and the adjacent, or adjacent and hypotenuse? Well, that's cosine. So I'm going to take the cosine of 53 degrees. And that's equal to the adjacent, which is 12, over the hypotenuse, which is what I'm trying to find. Remember, you have to use a side that you know and a side that you don't know when you set this up. So cosine 53 equals 12 over c. This is adjacent over hypotenuse. That's how we figured this out. Make sure you know that's a c there. It looks a little bit like an a. And then how do you solve this? Well, this is where people get messed up a little bit. You can't just multiply 12 to the other side. The c's in the denominator. You have to get it out of there. So you have to multiply by c to each side. So I have c times the cosine of 53 degrees is equal to, the c's cancel here, equal to 12, because you have to get c into the numerator first. And now how do I solve for c? Well, now I'm going to divide by cosine 53 degrees, divide by cosine 53 degrees. I end up with c is equal to, it's an approximation, it's 12 divided by, make sure you're careful here, 12 divided by the cosine of 53. And you hit enter on that, you get 19.93, so I'll say it's approximately 19.9. And that would be the hypotenuse in this case, right? So that's side C. Be careful solving this. A lot of people make the mistake here of, they can set it up, but then they solve it incorrectly, right? So you multiply both sides by C and then divide by that cosine. Make sure you're evaluating this part correctly. Cosine of 53, if you don't have a calculator that displays everything on the screen, you should evaluate that first and then do the division. The other problem I said to try out here, if you're trying to find angle B and side X, You know, we've got this triangle given to us, trying to find angle B. Well, they didn't tell us anything about the other angles, or angle A anyways, so you can't just subtract from 180 because we don't know what angle A is either. So it's not that easy in terms of finding angle B, but finding side X we could do pretty quickly because we know two sides, we just need the third. So for side X, what do we use? Well, we know two sides for the third, and the right triangle is Pythagorean Theorem. So 3 squared plus 5 squared equals x squared. Don't forget to square it. Sometimes when it's the hypotenuse, people forget that, right? It's the hypotenuse squared. 3 squared is 9, plus 5 squared is 25 equals x squared. 9 plus 25 is 34 equals x squared. And then we want to take the square root of each side. Remember, normally you would write plus or minus, but in this case, since it's the length of a side, you don't write plus or minus, say square root of 34. That's equal to x, and this is the exact answer, and we'll leave it exact. So the hypotenuse is equal to the square root of 34. How do I find angle B? Well, for angle B, remember how this is going to work. You have two of these sides you know, and you want to think about the trig function that relates them. Well, this is angle B, right? And I'm talking about this side and this side. How do they relate to angle B? Well, the side that's 3 is opposite of it. The side that's 5 is adjacent to it. So the trig function that relates opposite and adjacent, well, that's tangent. So it's the tangent of B, we don't know what B is, we're trying to find it, is equal to opposite over adjacent, which equals 3 over 5. And then how do you solve this? Well, we're trying to solve for an angle. When you're trying to solve for an angle, remember what you use. You're going to use the arc trig function, right? The second key on the trig function. So it's B is equal to the arc tangent. All right, make sure you have the correct notation. Don't write tan there. It's the arctan. So you need that tan with that little -1 indicating the arctangent. Or you could write arctan of 3/5. So then B is approximately, we'll round it to the nearest 10th. So we've got the arctangent of 3 divided by 5. Which gives me 30.96. So the 6 would round that 9 up to you know, the next digit, so that would become a 0, and then 31, so it'd be 31.0. And remember, this is measured in degrees because it's an angle. Make sure you put degrees on your angles. That shows me that you know what you found. So, you know, these examples are helpful in trying to figure out how to use the trig functions. I mean, the hardest part people usually have are with these last couple of examples where you're trying to solve for the sides. But remember, the trig functions give you a relationship between an angle and then what type of ratio between the sides you have, either the opposite over hypotenuse for the sine, the adjacent over the hypotenuse for the cosine of the angle, or the opposite over the adjacent for the tangent.